Good morning and good afternoon. This is Monica Paolini from Sensafili, and today we're talking about smart data and how the digital transformation is going to be able to leverage that to improve network performance and resource utilization. And I'm talking today to Dr. Vikram Saxena, who is the CTO Cable Markets at Netscout. Vikram, thanks for being with us today.
Thank you, Monica. Happy to be here.
So can you tell us what you personally and what Netscout is doing in this area?
Yeah, absolutely. I think Netscout is at the center of what you refer to as digital transformation in the industry. What digital transformation is all about is how to drive speed and agility in the environments that our customers are dealing with. So it's really all about that. And to drive that, it has to be driven by smart data. What we mean by smart data is data that has been refined for things that will enable the network to have that speed and agility. So in a sense, the analogy comes from the fact that when we look back at industrial revolution that was driven by the fuel that was the oil, and oil had to be refined to drive the efficiency in the industrial revolution. Similarly, when we talk about networks and digital transformation in networks and services, that transformation will be driven by this new fuel, which we call smart data. And smart data is nothing but data from the network that has been refined to serve a variety of use cases to make sure that the networks can be agile, dynamic, and can operate at the speed and agility of the customers.
How big of a change is this? Because there's a lot of debate. Is it just a little bit of making the network a little bit more efficient, or is it a game-changing type of change?
I think it's a fairly disruptive, game-changing environment because traditional networks, if you go back to look at the history of networking, IP networks, when they first started in the 90s, were fairly or relatively stable, what I would like to say. That, the environment they were operating in, whether it was internet and web services, they were fairly constant over relatively long periods of time. And therefore, the network could operate on the time scale of days and months and maybe sometimes even years because the changes were happening in that time scale. Now, what has happened is with the introduction of cloud and virtualization and those kinds of technologies, applications are becoming more agile. And therefore, the network that keeps up with these applications, they have to become more agile. So the speed has gone from days and months to seconds and minutes, and in some cases, even sub-seconds. So how do you operate this network at those high speeds is a fundamentally game-changing proposition. And I think this is where things like artificial intelligence, automation, using network data or smart data to drive all this is a fundamental change to how networks will be operated in the future.
So basically, the networks are becoming more complex. We know more about them. And so this is an opportunity to use that complexity and that knowledge to optimize. What is going on today? And we're going to talk about the future, but let's try to talk a little bit about what is going on today. What is that operators are doing right now?
Yeah. So, this is going to be a multi-stage transformation in the industry, right? It's going to take a while for it to play out. So right now, what is happening is operators are moving from a hardware-centric network to a software-centric network. So the first step has to be move to an environment which will be capable of delivering the agility. So the move that is happening is instead of going with proprietary appliances that are hard to change and hard to augment, go with a software model. And this is the whole revolution of NFV and SDN that started maybe like roughly 5 years ago, where the appliance model was decoupled and disaggregated, so you can have control plane and user plane running separately in general purpose appliances, and generally the control plane and the services were controlled all in software. So that allowed you to build an infrastructure that can then deliver these dynamic, agile set of services. So the focus has been it's like you need to lay the foundation. You need to lay the foundation before you can start building a house. So similarly, right now, it's the changes that are happening over the last 5 years and where the operators are now is in this middle of transformation from a hardware-centric infrastructure to a software-centric infrastructure.
And how well are operators doing? So they're moving to, they're transitioning. How well are they doing in being able to using the smart data to their advantage to optimize their networks?
So right now, the whole system is operating more in what I call an open loop fashion. In other words, the smart data is more being used to make sure that the customer experience, and the service delivery is happening without a negative impact on the customer. The idea of driving this intelligence back into the network is what we call closed loop automation. That phase has not yet been put together because it requires many of the pieces in the network to come together. So right now, what you are seeing is operators deploying, NFV and SDN technology in the network, and while being in a hybrid environment, they still have good parts of the network which are still running in the older hardware configuration, and they have newer parts of the network which is now running in a software model. And now they're trying to manage this hybrid infrastructure using technologies like Netscout, which gives you the ability to use the smart data to be able to provide a consistent end-to-end service, and then make sure that the services that were running on the old network are seamlessly migrated to the new environment. And then I think what will happen is, as this phase accelerates and some of the other technology elements come into place, the ideas of closed loop automation, where there are no humans involved, where they would then go and changes become more automatic and dynamic, that phase will happen. And that we are not there yet today.
Yeah, so you see this happening. Is there any bottleneck as you move from open loop to closed loop? What are the challenges for the operators there?
Yeah, so I think the challenge is basically to get the right technology in place in a way that is relatively simple and straightforward. Because the problem is, when you want to do automation, that you can also introduce a lot of complexity. And when you introduce a lot of complexity, the risk of things going wrong are higher, and therefore that slows things down. So right now, the challenge that the operators are grappling with is, what are the set of components that can be introduced minimally to be able to do, to be able to take this smart data, finesse it and refine it, and blend it with orchestration systems and policy systems so changes can be impacted in the network through a well-defined set of APIs. So there is work going on in defining those APIs. There's work going on in defining what the policies rules should be for making changes. And this is where artificial intelligence, machine learning, all these technologies are coming into play. But not everything is there in a way that you can now go deploy in the network. And also, you're also limited because the hardware side of the network is running on own technology. It's not easy to make changes there. So therefore, if you only make changes in the software side of the network, you may not impact the agility of the entire end-to-end service. So I think that the evolution to a software network needs to take place some more before you can start to automate at the service layer, because if a good chunk of your network is still running on legacy technologies, it will be hard to automate all that.
Yeah, absolutely. So, and there is a lot of work, but so the goal is to be agile, to run basically in real time, to have networks that are more dynamic.
Yes.
So how do we get there? What is that operators have to do to get there?
Well, so I think what the operators, what Netscout is doing to help the operators, basically, take this, large set of network data and then really distill it down to what we call high fidelity data and separate it from the low fidelity data. Because a lot of data that comes from the network doesn't have the granularity that will allow them to drive these kinds of changes that they're envisioning. So our job is to focus on that data set, which comes actually from monitoring user traffic, that data set, which is a high fidelity data set, that will give you all the information about applications, services, the subscribers, and the network technologies that they're operating on, all the way from layer 3 to layer 7, let's say, and then make it contextual, make it real time, make it actionable, and make it structured in a way that these data sets can be manipulated in a relatively straightforward and simple fashion by the upstream applications to be able to drive this. So the underlying infrastructure where smart data will begin to play a key role in driving this transformation is where we are helping the operators, and that's where we are educating the operators. We are working with them to go down this transition, because if they don't latch on to the right data set, if they keep working on this heterogeneous mix of data set, it's going to be extremely challenging to use data to be able to drive all these changes. So where we come in is to help them understand and start using the data set that will make this transformation go faster.
Now, one thing that sometimes you hear from operators is that clearly that's that the goal, it's a good goal. But to get there, there is so much data and it's so difficult and they feel overwhelmed. Yeah. And how can you help them to sort of overcome this feeling of like being snowed under all the data that the network produces?
Well, that's a very valid point, and that's exactly the reason why many of the big data projects haven't been successful in delivering the value that operators were expecting them to, because there is a flood of data and they don't know how to extract value from it, right? So this is where I think what they have to step back and look at it is the data that has the most fidelity and the most granularity to be able to drive it. So if you remove, it's the 80-20 rule. The 80% of the data they get from the network today doesn't have the fidelity. The 20% of the data has the high fidelity. And that's the data that Netscout processes. So if you standardize or kind of build a foundation around smart data, and then layer in other data sets if and when necessary, as the demand dictates or as the traffic dictates, then it becomes a much more effective environment. The problem comes now is they start with this large data set, which is not very effective, and they immediately run into this problem of how do you cope with this data. So I think the answer to this puzzle is start with the data set, which is what we call the high fidelity smart data set, and then build your underlying infrastructure on that, because you can do a lot with that. And once you do that, then you need a sprinkling of other data sets. You don't need to manipulate and capture the rest of the data that's coming from the network, but they can do it selectively and then augment the smart data with selected data sets to drive different use cases.
Yeah, so basically you need to find what's relevant and throw away the rest, or put it on the side and then
put it on the side and then pick and choose as and when you need it, right? So I think you need to have this core data set that has the highest value and build on top of that.
Mm-hmm. Yeah. So can you tell us a little bit about what is your approach at Netscout in doing this? Because there's not, AI and it's not just something you get off the shelf. There's a lot of work in terms of how you approach it. What are your choices there?
Yeah, so let me talk in terms of, two layers of functionality. One is the functionality that sits closer to the network, that is monitoring traffic and extracting the metadata. And the second layer is what we call analytics, where we build a lot of intelligence like AI and machine learning to be able to do things more predictably, right? So at the first layer, what Netscout does is it created this technology called adaptive service intelligence, about a decade ago, which is really the most efficient way to capture the relevant metadata set from network traffic. So what we do is we look across all the packets going in the network from a user to an application or from one user to another user. And then in real time, we extract from this packet data all the metadata that is relevant for that particular service. So if it's a voice service, we look at control plane, we look at user plane, we look at who the subscriber is, we look at where the two endpoints are, and then we monitor all the metrics like the time it takes to set up the call, the time it takes to get to the particular user or the application. And then we also look at in the user plane, how the quality of the voice is behaving, and we extract all that metadata in terms of the fidelity and the quality of that user plane data. Similarly, if you're looking at a video traffic, we do the right metrics for the video traffic, and we do it all in real time, and we package it into the smart data data set that is then sent upstream to the analytics application. So when we capture all this data, there is actually a reduction of more than an order of magnitude in the data that is then compressed and sent upstream. So 10 to 1 to 20 to 1 to 50 to 1 data reduction that happens because we have taken all the valuable pieces of information from this data on the control plane and the user plane and then packaged it in the right format so that upstream applications can then take advantage of that. So that's what we do, which is fairly unique in the industry because to do it at the scale, to do it at the volume of traffic that we are dealing with in very large operator networks, and do it all that in real time and send it upstream is an extremely challenging task. It's not easy to do that because you're talking of terabytes of data crossing your network. And then on the analytics level, what we do is now we build different use cases. There are subscriber-centric use cases to maintain customer experience, reduce churn, or there are network-related use cases for operations teams to make sure that the network is functioning without a hiccup, or to the security teams where they're looking at anomalies to see if there is any anomalous traffic that is trying to disrupt the network. So there are many, many use cases that the upstream applications create from the same data set, from the same metadata that gets created. So this is the Netscout value proposition. This is where our technology plays a very key role. So.
And how do you do it? Because in a virtualized network where there is not only it changes through time, but it also changes how the functions are, executed. How can you do this? Because clearly you have to do it in real time, but also in terms of the different components. You cannot just monitor one component because there is no such thing anymore from a hardware point of view.
Yeah. So in a virtualized network, we put our instrumentation technology in different points in the network which are strategic to extracting the smart data. So if you look at a mobile network, we sit at the edge of the RAN, we sit in the core of the network where the sessions are being terminated, then we instrument in the IMS infrastructure where the session-oriented traffic is being handled. So in a network, if you look across all the way from the edge to the core, there are instrumentation points where we deploy technology. Now, when we go virtual, the problem gets a little bit more complex because unlike the hardware environment where we can tap physical wires and extract packets, in a virtual world, it becomes much more complicated because all of this sits inside a server. There is a hypervisor. There are a container environment. There are a multitude of different ways that people are deploying technology, whether it's at the edge or in the core, and different technologies are being used. So we need to instrument it in the right way. So we can sit in a hypervisor as a plugin. That's one model. We can sit on a container bridge where we are monitoring a whole bunch of cloud native functions that are deployed as microservices. Or we can sit as an agent next to an application in a public cloud. So what we have done with our instrumentation technology is to create different footprints and different packages that can be deployed all the way from the edge to the core with the right kind of infrastructure. So some people are using OpenStack, some people use VMware, and there are different techniques for extracting packets in these environments that need to be very efficient so they don't create an undue load on the environment. So we have very efficient APIs and plugins that we use in different environments that are optimized for those environments. And the other challenge is to create it in a very lightweight so we don't consume a lot of resources. So that's another optimization that we have done. So
right. Yeah, you don't want to create too much of additional processing as you do that.
Yeah.
But
because all environments are resource constrained, so we have to be very cognizant.
Yes, you have to be, but at the same time, you need to have an end-to-end overview of the network because you cannot just look at the RAN or at the core or a specific function or a specific functions. You have to put it all together.
Yes. So because we focus on the service layer, which is what the end customers care about, service by definition is end-to-end. When you're monitoring network elements or network components like a switch or a router, that's a very different approach because then you're looking at specific elements in the network. You're not looking across a service which is going end to end. So our focus always has been at the service layer, which by definition is end to end. So whatever we do at different points in the network, we need to put it together into an end to end view.
Yeah, yeah. So is this a cloud-based type of solution?
So the implementation follows cloud-native methodologies.
Mm-hmm.
We package this in either containers or virtual machines that can be deployed using any of the cloud-native technologies for automation, for deployment, for auto scaling, for auto healing. So essentially, the technology is packaged to be deployed in a set of cloud-native functions.
Absolutely. So, final question for you. 5G is an obligatory one, but let's think about 5G and the future. How is that going to change the way operators deal with smart data?
So 5G moves to a different architecture. I call it more disaggregated network. When you look up to 4G, the networks were highly centralized because you had all the intelligence was concentrated in the core of the network. So while it made it easier to manage the network because the more functionality in the core, it's easier for operators because there are only few places they need to manage. But it became very obvious that this architecture will not serve the next generation applications which require either very low latency or very high throughput. So when you have either of those cases, what you need to do is disaggregate the network into an edge and a core. And this is what 5G is fundamentally all about. It's disaggregating the RAN, it's disaggregating the edge and core functionality in a way that this notion of edge cloud is something new that was not there in 4G that's now coming into place. And the function of edge cloud is twofold. First is to manage user plane, because the user plane is what's going to move to the edge, because that's where the latency and throughput is going to be measured. The core functions will be mostly control plane oriented, and those functions will still stay in the core. So now there is a separation between user plane and a control plane, and that represents challenges from a monitoring and assurance point of view, because when you have these things being monitored in different places, you need to be able to correlate them together. So this whole idea of control plane, user plane separation in 5G is a very new idea, and this idea has a lot of power, but it needs to be managed properly, and we can help them do that. That's number one. Number two is when you move user plane closer to the edge, you need to be able to monitor the actual application itself. So it's not about managing connectivity, but it's about managing applications. So if you're delivering an AR, VR application or a connected car application or an autonomous vehicle application, you have to measure the latency on all this, because that's what the applications are all about. So if the latency is exceeding what the applications really want, then you can manipulate the network to reduce that. So monitoring application layer performance like latency and throughput is going to be very critical. So that's the other challenge in moving to 5G. So what we have done is optimized it for these two capabilities: control user plane separation and correlating control and user plane, so you can construct the session on an end-to-end basis, and managing key user plane characteristics like latency and throughput more at the edge of the network.
Yeah, absolutely. So so that is going to be a fundamental difference in the way we organize networks.
Yes.
Okay. Well, Vikram, thanks for talking to us and sharing your views with us. It was a great conversation. Thank you so much.
Thank you, Monica. Happy to be here and happy to talk about it.
And thank you all for listening in.